Hey everybody, Happy New Year. Happy New Year, Kay. Thanks for saying that. Can you confirm or anybody confirm that you guys are hearing me and also seeing the screen? That would be great. I've had problems in the past. I want to make sure that I am streaming successfully. Awesome. Thanks, Kay. Perfect. Okay, so let's get started. Um, today's topic today's webinar is we're going to look at CatBoost. Um, uh, CatBoost is a phenomenal boosted tool, gradient boosted tool. I'm a big XGBoost fan, and I've done other videos before on XGBoost and CatBoost, kind of a comparison. You can go to my site at viralmail.com, and if you hit the data science button, you'll get my data science section, and and here's a video I did recently called CatBoost versus XGBoost. In this video, I just kind of want to cover looking at CatBoost on its own merits, and also looking at the classification and regression. Quick classification example, quick regression example with CatBoost is definitely a model that I am looking at a lot closer now. I've used XGBoost professionally for many years, and there are definitely some speed advantages and even accuracy advantages with CatBoost. So welcome to the ValMail Show. My name is Manuel Amunategui. Please sign up for my newsletter if you haven't already. It's right here in the middle of the page at viralmail.com. Also, the code I'm going to use in this example is super simple, and it's based on the examples that you have from the CatBoost site. So there's going to be no source code, but if you really want it, just email me. Either respond to my newsletter if you're a member of the newsletter, and just say, hey, I want the code for the CatBoost webinar, and I'll gladly send it to you. But otherwise, it's very straightforward. And this webinar will be classified under webinar right here. You click the red button, webinars, and you'll see them, and I'll put this one once it's finished there as well. So, quick overview, right? This is from catboost.ai. The overview, they call it a machine learning algorithm that uses gradient boosting on decision trees, and it's available as an open source library. And here it kind of highlights some of the key features. Training. That's good. We can do training. We can train models. That's good, but it can work on GPU. It does cross-validation, which is cool. It has an overfitting detector that we'll look at in a second. It has pre-trained data. I think that's pretty cool. I haven't used it, but my understanding is that you can train something, play around with it, and then save kind of the weights that you have and start training from those weights and keep going, right? And that's actually pretty cool. Something I wanted to do in the past, and I never really knew how. So I'm going to play around with this and maybe make another video if it proves interesting. And it also has a lot of categorical tools out of the box. When in XGBoost, you kind of had to dumbify, you kind of had a one hot in code. It's actually recommended in CatBoost to not do that, to use their built-in categorical features, and I'm going to show you how that works here, which is actually really cool because it makes our lives a lot easier. As far as I can tell, it works for the usual suspects, Python, R, and all that stuff. And I saw something briefly that caught my eye. You can actually use TensorBoard also to play around with it. So there may be even a way of using CatBoost without doing much coding, which will be interesting. We're going to be focusing on Jupyter notebooks. So let me go back to the Jupyter notebook here. And again, if you want this code, just send me an email, and I'll email it to you after the show. We are going to look, we're going to start with the CatBoost classifier. So you will need to install CatBoost. It's a simple pip install CatBoost. That's simple, right? Straightforward. And they also have, like a lot of these, they also have data sets that are built in. So I'm just going to, out of laziness, I'm just going to work off of the one they have, catboost.datasets, and we're going to pull the Titanic, which is a perfect example to do a classification. So I'm pulling it out. We're going to do a head, and we're going to look at the shape. So as you can see, it gives you a Titanic underscore train, a Titanic underscore test, or that's the variables I'm assigning it to, but it basically gives you a training portion and a testing portion. The training portion is 891 observations. The testing portion is 418. And these are the values that you get out of the box. It's typical Titanic. For those who don't know, Titanic is the tragedy at sea of the boat that went out, and it was actually really predictive who survived. So this is kind of your outcome column. Whether you survived is a 1. If you didn't survive, basically you drowned or you died, it's a 0. And it was very predictive, like gender. Mostly the females survived, the males didn't. The age was predictive too. The younger survived, the older didn't. And the class was very predictive as well. The higher the class, the more your chances of survival. So you're better off in first class versus third class. There's also, I think, the third class were at the bottom of the ship. It took them a long time to get to the raft, to the boats, right? To the safety boats. So this is kind of the fields it gives us. And we are going to, another tool I'm going to introduce here, something I'm using a lot more at work these days, is called Pandas Profiling. So Pandas_profiling. And it's really cool, especially if you like to do EDA, or your work requires you to do some data exploratory before tackling a project. And it's something that we do at my work. We make sure that everybody kind of comes up with these reports and tells us why they're using a particular feature for a model, right? They kind of have to defend their position. I think this feature is important because of this, So EDA or heuristics research is really important. And everybody has their own tools, right? Oh, I like to use this, I like to use that. And R kind of, if you do like you right click on a data frame in R, you can get all these really cool information about the data set. Now you can do that with pandas as well in Python by using this library called Pandas Profiling. Let me show you briefly what it does. So you basically pass it your data frame. So it's got to be a well-formed data frame. In this case, I'm passing it Titanic_training, so the training portion, and you just pass it to whatever you instantiated your object and .profile report, and it returns this overview, which is a high level, right? It's kind of like if you did the shape, description, the length, all that stuff. It'll tell you the number of variables, the features, the rows, high level missing, how many missing you have, the duplicates. It'll also break down the variable types, which is cool. We say we're dealing with numerics, categoricals, booleans, and even one text. And it gives you high-level warnings. So right off the bat, I think this is really cool. For example, warning here, age has, we have 800 and some rows, right? We have 891 rows. So out of those, 177 have missing values. So that's good to know, right? So here is age we could impute with the mean. That would be a good way of going. Cabin has high cardinality, meaning that a lot of the values are unique or different. So this tells us that 148 are different values, and 71% are missing, right? So that 77% are missing. So that tells you right off the bat that cabin is going to be a tough feature to work with. Fair has a bunch of zeros in it, and ticket also has some cardinality. 681 distinct values. Remember, we have 891, so also the ticket number may be a tough one to model. Okay, that's cool. And then it drives down into each variable. So the age, it gives you a distribution, which is nice to see, right? So we can see this distributes kind of normally. Tells you a bit about the missing ones. It works on categorical values as well. Here it tells you that most of them, like 148, are distinct, and we're missing a whole bunch. So that tells you it's going to be tough to work with. Embarked is one that I'm going to use because it's a categorical. It tells you this is categorical, which is cool. And it kind of tells you, look at that, nice distribution of the categories. We have, S has 644, C 168, Q 77, and only 2 missing. So this is definitely something I'm like, okay, yeah, I want to put that in my model. Okay, and so on and so forth. Okay, so that's Pandas profiling. And the last thing, it gives you some nice correlation plots, and that's really good when you're doing heuristics to quickly tell if there's any simple, correlation with 2 different variables. So right off the bat, you can see age. We know that age and survival is important, and so let's see, age and survival. So it says, yeah, it's a little light blue. That's interesting. I would have imagined more. The class and the fair, very blue, meaning that's very positively correlated, which does make sense, right? The people who paid first class had to pay more money, right? So it tells you how that works. And this is basically, this is a good process to do when you're doing you're tackling a new data set for a job. And kind of gives you a heat map, which is cool, matrix dendrogram, kind of relationships between these features. Pretty cool. Okay, so now we have that. It kind of tells me that from looking at the information, in order to model with CatBoost, I'm going to use these 4 variables. So off the bat, because the Titanic dataset is such a famous one, we already know that class, sex, and age are critical, right? But because I like the fact that there was a lot of values, there was not much missing in Embark, I'm going to throw it in. So what you need to do with CatBoost classifier, it's super easy. Actually, we're not using pool and we're not using the cross validation. So let me just remove them so we don't get confused. So you call, after you install it, you call CatBoost classifier. You got to tell the model that you're going to be using a classifier. I like to declare my outcome name, so I can just work with this variable instead of the actual name. And I also like to separate my features from model, which are basically what I want to model. So if I'm going to model the whole data set, I'll say everything that's not the outcome. But in this case, the majority of them I don't want. I just want these 4 for modeling. So basically, I'm going to say everything. Features for models are just these 4, right? So that does not need to be there if we didn't want it, right? I'm going to use the train test split. Right now we're all using that from sklearn, and we're going to do a training and testing split. So we're going to be left with x_train, x_test for training and testing, and y_train, which is our outcome variable, so whether the passenger survived or not, and the same thing for the testing portion. We are doing it 30%, so 70% for training, 30% for testing, and I'm always setting the seed, so make sure that we can, these things are always reproducible, very important. So this is one thing you have to do with CatBoost, which you didn't have to do with XGBoost. You have to leverage the categorical tools built into CatBoost. You have to tell CatBoost which one are categorical. So this is actually, I didn't come up with this. I found this code, an example. I thought that was pretty clever. It's basically saying anything that is not a float, considered categorical. So text will be considered categorical, an object will be considered categorical, and obviously integers will be considered categorical, right? So it's not always a case that an integer is a category, right? If you had like a fuel gauge that had buckets 1, 2, 3, 4, 5 kind of buckets, then this would say it's a category, which it really shouldn't be a category, right? But in most cases, an integer is a category. So this is pretty clever. It's basically going to say everything but age. So 0, 1, and 2, 3. 0, 1, 3 are categories, and age is numerical, right? Because I think age is float. Let's see. Actually, that's interesting. I wonder if it takes it as a float or an integer. Let's find out. Okay, hold on. Let me move these into memory. There. 0, 1, 3. So age is indeed taken as a float. I think there are some decimal points in there. That's why it's seeing it as float. Otherwise, age would be seen as a category. And that's an important point to bring, right? You wouldn't want age to be a category, right? You'd want it to be as a continuous number. But this does it fine. So we know that it's going to give the model 0, 1, 3. So it's going to give class, sex, and where they embarked as categories, and then it's going to be up to CatBoost to do to say, okay, these 3 features are categories. You'll have to do, I don't know how it does it inside, but you'll have to do its own one-hot encoding. And then you create a dictionary. This is very much like we did in XGBoost, a feature dictionary, a parameter dictionary, where you give it the number of iterations. We're going to do it 5 iterations. The learning rate, right? If it just doesn't converge, try a bigger number. If it converges too fast, try a smaller number, kind of deal. We're going to say this is where you pass it your categorical features, saying, okay, these, those three features are categories. Treat them accordingly. The depth, how many features you want, because our data set is super small, right? We only have 4 features. I'm saying just use 2 per tree. That's fine. And the evaluation will be AUC, area under the curve. So we're looking for a score to go up, not to go down. And verbose, we want, because this is a lesson we want to learn, we want to have as much information as possible. Then we run the classifier, the CatBoost classifier, you pass it your parameters, and now you have instantiated your CatBoost classifier ready to go. Now all it needs is some data, right, to run the model. And it's super simple. It's just .fit. You pass it your training, your training outcome. You tell it what's your evaluation data set. So we're going to give it our testing and our testing outcome. Use the best model, right? So it will when it when it ends, it'll tell you which was the best model. And this is pretty cool too. It has a plot feature, so you can see a little bit how it's working. It's a bit kind of like TensorBoard, which gives you a lot of visuals. When I'm running in production, I'll turn this to false because I don't need that. But for us, it's pretty cool. So let's run it. And there was an error. Let's see, what was the error? Oh, there are nans in there. Where are you? I forgot to run this. That's another thing, very important. I'm glad it crashed on me. Very important. Unlike XGBoost, CatBoost, you have to deal with your nans. You cannot run a model with the nans, and I think it's a blessing and it's a curse at the same time. In XGBoost, all the time you just throw your data. It says, "Oh, XGBoost can deal with nans," because oftentimes people see nans and not a number as its own category. So he says, "Oh, let it deal with it." And I've tripped a bunch of times for a variety of reasons, and that's kind of cool. It forces you to deal with them. So I'm just going to force them all to -999. And run this. And now we have basically, there's no more nans. And that's something I forgot to do first. So let's go through this again. Actually, let me remove this. Let's remove this there. And let's run the model now. It's pretty fast because this is only a couple hundred rows. And look at that, right? We clearly see that it started iteration 0 here. It jumped from 0.73 AUC to 0.785, and it ended up at 0.81 AUC, right, with not much work. So pretty high, very accurate, right? An AUC area under the curve is going to be anything above 0.5, and closest to 1, the better, right? 1 means it's predicting everything perfectly. And look at that. It tells you exactly, because we have verbose set, it tells you that the best iteration was iteration 3, and the testing on our testing data was 0.8 AUC, area under the curve. So not bad, right? And you can also do, which is very important to me, you can do feature importance. That is super important. Whenever I'm talking with anybody, like a customer, they always want to know which were the features that were the most important, why, etc., etc. So it's not super simple. It's not like .variamp in some other models, but you still get there. You have to pass it the features that you want to model and the trained model, and you do this function called get_feature_importance, and then you have to do a little data frame magic to make sure it's nice and clean, and it will return the top features. So here we see sex, the gender, right, of the passenger was the most important to the model, followed by class, very important, right? This is where like basically a sex and class were the most important. Age, not so much, and what I thought was going to be important, embark, turned out to be completely useless. That's fine, right? No big deal. And now we have a trained model that you can call predict on it, and you can predict, if you want it on a new data set, unseen data set, or live data set. So that's the classification portion, right? So super easy to do, super fast. Let's look at regressor. If there's any questions, please post them. I'll be glad to try to answer them. I'm still also a bit new at the CatBoost. So CatBoost regressor, same concept, just a few differences. First of all, we need to have a different data set, right? The Titanic was a classification, whether somebody survived or not. Now we're going to use another data set, another famous data set, the Boston house price data set. It's been around forever, and it's about houses that are sold in Boston, and it has a lot of environmental things like crime, pollution, these kind of things. But it also has kind of a price, a medium price, and that's what's important to us. So this one is also as easy to get. We simply call the sklearn.datasets. We're going to load Boston, and we can. It's very easy to do. It tells us it has. This is what comes out of the box, not very useful. We want to get to the data part. So then we have to wrap that around a data frame called Boston dataset_dataset.data and the columns, feature names. And now we finally can see what it has under the hood. It gives you the crime, the industry, I think the age of the house, also the tax, all sorts of interesting things. And it also gives you the medium value of the owner-occupied home in, it looks like thousands of dollars. That's the target. So we have to call the target and add it to it. It splits it out for you. And now you have all the features for the homes plus that target price. And that's basically perfect for a linear regression, right? It's a continuous number, the price of a house based on these features. Perfect for us. So let's run it through Pandas Profiling again. It's always a great idea to see a little bit what you're dealing with. And I've already run it here. Let's see, we have 14 variables, we have 500 rows, we have nothing missing. That's pretty cool. No duplicate rows. And let's see, everything is numeric. Oh, we have one Boolean and we have one rejected. Why is it rejected? I don't know. Let's see. Oh, tax is highly correlated with RAD. It looks like RAD or ROA. RAD, right? So that's interesting, right? It tells you right off the bat. This is just it's correlated at the p correlation of 0.91, right? Pearson correlation 0.91. This means it's practically the same thing. That's really cool, right? It's rejecting it for you automatically. I love it. Zn, remember, has 372 as zeros, so 73.5% of Zn, the zone, is a zero, right? So it's giving you warnings. It's not, it's not. You can still use them. Like this zone may still be interesting, right? If the zone, let's say there's what is zone? Let's see. Well, let's jump to zone. Let's see if it's categorical, 0 and 1. Here it is. Look at that. Yeah, it's all zeros, and then it's not zeros. It's zeros and then some numbers, right? That's interesting, right? So this would probably call for some feature engineering and to see it closely. What does it mean when it's zero? What does it mean when there's a number? And here is the median price. We can see it's always good to look at the distribution of the price, and we see nicely distributed, right? So that looks good. And we have a bunch of other things. Crime. I'm not quite sure what these things mean. But there is a way of seeing what they mean. If I'm going to scroll down here, part of the Boston data set, there is a description field, and it tells you a little bit, right? Zone is a proportion of residential land zoned for lots, and it gives you all sorts of other information, right? So we're not that concerned about the data set itself. We really just want something that we can run a linear regression on. But all information is there. Okay, good. So missing values, sample first a few for top rows, bottom rows. So now we want to run the CatBoost regressor, just like we did for the classifier. We call CatBoost, import CatBoost regressor instead of CatBoost classifier. It's that simple. And now we have a CatBoost that's ready to do regression. And I'm going to use the same template I used before. My outcome name now is not survive, it's med, the medium value of the house in thousands. And here I'm actually using it what I'm doing. Anything that's not the outcome is something you want to model with, right? So I'm saying everything you can model with, even though the Pandas profiler told us don't use this, don't use that, I don't care. This is quick and dirty. I'm going to say everything that's not the outcome variable, run the model. Okay, fine. Same deal we did before. I'm going to split this Boston data set into two data sets, one for training, one for testing. Same split as before, 70% testing, training, 30% testing. And you pass it your random seed as usual. And now, same thing, right? If there's a categorical value, give it a categorical. And I think there were some integers, so that's going to be thrown into the categorical pool, which is fine. And here we're going to do, the parameters are a bit different. So that's one thing you have to keep in mind if you're doing the parameters for a regression are different than the classification, which makes sense. The iteration is the same, learning rate is the same, but here you'll have things like, which I'm not using apparently here, but you'll have a L1, L2, those kind of loss functions. We are going to use a root mean squared error. So that means that we want our scores to go down, not up like what they did with the AUC. Setting the random seed. Here, this is also pretty cool. I'm saying this twice. Let me remove it. I only need it once. Here we're saying this is interesting. It's the overfit detector. So it's saying if it overfits, basically if it's not if in this case the RMSE is an error, if the error is not decreasing anymore, but maybe it's decreasing in the training but not the testing portion, it's gonna start saying, okay, there's overfit going on, let's eject. But here we're saying wait 20 rows before ejecting, right, to make sure that it's not just noise, that you're thinking you're overfitting but you're not, right? So these are two features that are pretty cool that you can tweak to make sure that you're not automatically ejecting based on noise. You want to make sure you really are overfitting. And the rest is the same, right? You just call in this case is a regressor, we call regressor, and everything else is the same. So let's run this. And here it is, right? Our root mean squared error means that you want to get your error to go down. Oops. And sorry about that. There. You want your error to go down, which is good. Look at that. It is going down as we're going through our iterations. Remember, we're doing a lot of iteration, I think 50,000 iterations. And we keep going down and down and down. And you have the overfit detector, so you can you can give bigger numbers, and hopefully it will figure out automatically, hey, we're not getting any better. Let's break, right? So I asked it to do 50,000 rounds, and with a fairly tight learning rate, and it did a good job. Look at that, right? Keep it going down, 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 down. And let's see, so I did a bunch of verbose was turned on, so we got all sorts huge log report. But the RMSE was, the last RMSE was 3.3, which is interesting because it started to even though the learning rate was 2.9, here you can see that it's kept on going down. Oh no, we could have kept going actually, right? Look at that, it ejected right at the end, so we could have kept going. Like the last test, meaning that in this case, either you want to make your learning rate a little bit bigger or give it more iterations, right? But it looks like it could still do better because we basically, I gave it 50,000 and it was still, the error was still decreasing at 49,999. Okay, well, we don't care, right? This is again just an exercise. Same deal. Let's do the feature importance, and we see LStat is the most important, followed by RM. So RM I know is rooms. Obviously the number of rooms are going to be very predictive for the price of a house. LStat, I'm not sure what it is. Let's see what it says. LStat is percent lower status of the population. Yeah, it doesn't help me. But apparently very, very predictive. I think this might be some kind of social indicator. Is it an expensive neighborhood or poor neighborhood or a medium, a middle class neighborhood, that kind of deal, and which obviously would affect the price enormously. So all things to see. Hey, thanks, Marcos. Marcos is saying he likes this CatBoost. I love it too. I think it's phenomenal. And so that actually this is all I wanted to show. We're right around the half hour, so this is perfect. Like I said, I am taking CatBoost very seriously. I've used XGBoost for years, ever since it came out, and CatBoost has really made me use both, and I think it's interesting. One thing I noticed is when I'm doing feature importance on a same type of setup with a CatBoost or XGBoost, they seem to pick up, it's not always exactly the same, which is very interesting. And what makes me think is that maybe you could use ensembling, right? You could use both and average both outcomes or predictions, and maybe you could get a lift that way. And there's a question here: for small projects such as the ones you are tackling this evening, do you recommend shuffling all the data because using the model? Thank you very much. Oh, you should always shuffle all the data regardless of the size, and you do this automatically. This is a question from Rio the cat, and you should always do that, and it's done for us automatically here. So when you are, you always want to be careful, right? Because I've gotten burned by that many times when the data is in some kind of order and you don't want it to be in order. By passing it to this sklearn model underscore selection, it will take your data set, right? This is the training underscore Titanic underscore train in this case, and it's gonna randomize it completely, shuffle it completely, and then it's gonna split it into two test sets, right? And that's going to be it's going to be randomized for you. There's really no situations you don't want it to be randomized. If you do not want it to be random. If it's not random, it's going to give you trouble, right? That means it can peek into the future or whatnot. If you're working with time series, then you don't want to do what we're doing here. You want to do either pivot the data into stories or use more of a sequential model, right? And that's something I've wanted to do. I use these classification models for time series data all the time, but you have to treat the data as a story and basically pivot time into 30-day chunks or whatever, just like you would with Keras and Windows. So yeah, so you always want to shuffle, always, and this will do it automatically for you. You always want to kind of try to let the machines do most of the work, because if you do stuff manually, that's when you introduce errors and bugs. That's why I really like that Pandas profiling code I showed you. I'm trying to push my people at my job to use this because we do EDAs all the time, and it's just nice to have this report everybody is using. It always looks the same. And EDA can be very complicated, right? You're trying to learn heuristics, you learn the data behavior at a very minute level that is going to be different all the time. So you start with this and then you build on top of it depending on what the business domain is, right? And you can flip again. Hey Marcos, from Hola amigo. I will say hi from Barcelona, where I'm at right now. So if you want the code, please, and I think I recognize a lot of names, but either way, you have my email. If you want it, just send it to me. I have not put it up yet. I don't know if I will, because a lot of them it's not really my code. It's stuff that I've taken from these examples. But if you do want it, because you just don't feel like going through the examples or CatBoost AI, just you can sign up for my newsletter, and you'll get my email, and just reply to the email and say, hey, send me the webinar code for the CatBoost, and I'll know it. Remember that I have a lot of videos, so just tell me exactly what video you're referring to. In this case, the webinar for CatBoost, and I'll gladly send you this exact this exact output. It will be like this. It won't be very much clean. There won't be much explanation. It'll just be quick and dirty. Awesome. So and if you guys end up using CatBoost for your projects, definitely do that. And just to this CatBoost, you can use it for small and big projects. That's what I loved about XGBoost. The same thing. They all work in distributed environments, right? This, as we can see, it works on GPUs. CatBoost works on GPUs, and XGBoost worked on GPUs as well. You can use it, for example, in Google Cloud. The the machine learning. I forget the name. But basically you can use it in distributed setting, and this one as well, right? So you can use it for very small projects, right? Like what I'm showing you here, I use it on my local machine, and you can use it for terabytes of data if you mount it in the cloud, right? That's what's powerful with these types of classification models, is you can really do it at scale. Sometimes you don't want to do it at scale, right? You want to take a sample, model it, and then do the predicting at scale, not the training at scale. But sometimes you can't afford that either, right? It depends on the situation. Awesome. So hey, again, everybody. Thanks for watching. I'll plug, like I like to do at the end of my shows, I'll plug my school. Go to valmel.com, hit the school button, and here you'll have my tracks. I would, for what we're talking about, CatBoost and this kind of classification and importing to the web, I would recommend the machine learning track. Click on that one, and you have the course 1 is free. Simply just need to sign up for it, right? Even if you're on a newsletter already, just sign up, and it's automated. It will send you all the ebook, the teachable links for the videos, as well as the location of the Jupyter extracts. And then we dive into deeper, right? We do a lot more. This is an intermediate class, and then the advanced class, where we do a bunch of case studies, ranging from work with natural language processing, Google Maps, financial data, all that cool stuff. Awesome, everybody. If there's no other questions, I will end the stream. And as usual, you all know how where to reach me. And big thanks again.